Welcome to the Explainer. Look, today we're tackling something huge. We're cutting right through the massive hype surrounding enterprise AI to uncover an unglamorous but absolutely vital truth: data infrastructure. We're going to see exactly why the foundational layer of data governance is the ultimate prerequisite for making artificial intelligence actually work in the real world.
Let's kick things off with a question that's probably echoing through executive boardrooms everywhere right now. Why do out-of-the-box AI agents confidently hallucinate when you plug them into standard enterprise resource planning systems, or ERPs? I mean, you hook up a sophisticated autonomous system to your enterprise data, expecting this unprecedented productivity, right? But instead it just fabricates realities rather than actually executing tasks. Why does that happen?
Well, the result of those hallucinations is a genuinely staggering failure rate. Industry research shows us that a massive 70 to 85% of generative AI deployment efforts completely fail to meet their desired return on investment. That is a massive chunk of effort, just falling flat.
To put that into perspective, the standard failure rate for traditional IT projects sits somewhere around 25 to 50%. So generative AI projects are crashing and burning at a much, much higher rate. This huge disparity really highlights the severity of the data readiness gap. Basically, we're rushing to deploy AI without the mature enterprise data required to actually support it.
Okay, let's dive right into Section 1, Anatomy of AI Hallucinations, Understanding the Breakdown. We need to look under the hood here and figure out why these probabilistic large language models, or LLMs, keep failing. When an AI agent relies on standard ERPs or unstructured data swamps to ground its answers, it hits a few catastrophic barriers. First up, the perception layer and network blocks. If an agent tries to access external sites or secure endpoints, it often hits anti-bot measures, Cloudflare challenges, or those dreaded 403 forbidden errors. Without guardrails telling it to halt, the agent is functionally blind. So what does it do? It tries to reason its way out, usually generating an answer from outdated training data. Then, there's missing semantic business logic. ERPs are great. They're highly optimized tables for transactions, but they lack context. If an AI looks at payment history in one table and a refund policy buried in a separate PDF, it just doesn't have the ontological map to connect them. And finally, governance blocks and blind spots. Strict security and role-based access controls mean that if an AI isn't provisioned properly, it hits a wall. But remember, probabilistic models don't just return a simple error. They often try to construct a plausible-sounding but completely fabricated answer using fragmented data.
Now, all of these issues compound into something known as model drift. This is the steady degradation of AI performance caused by interacting with flawed, inaccurate, or outdated data. When an AI model ingests bad data, its performance just steadily drops. And the worst part? Bad data doesn't just limit performance, it acts as a massive force multiplier for chaos, actively undermining the trustworthiness of the entire AI initiative.
So the crucial takeaway here is that data quality is multidimensional. Poor data quality directly triggers this model drift across four very specific areas. First, we have accuracy. Think of everyday human errors, like a mistyped phone number or an incorrect decimal point that ends up corrupting downstream analysis. Then there's completeness. This is when datasets with missing fields or undocumented attributes leave the AI forced to just guess the missing variables. We also struggle with consistency. That's a lack of uniformity across different sources, which leads to contradictory truths. And finally, timeliness. Outdated information causes AI agents to make decisions based on completely obsolete market conditions, which is definitely not what you want.
Moving on to Section 2, the intelligence ceiling, why centralization isn't enough.
To combat those raw ERP limitations we just talked about, enterprises poured millions into data lakes, which are massive centralized repositories for raw data. But here's the catch. Simply centralizing data doesn't grant it semantic meaning. Without strict governance, data lakes quickly devolve into data swamps where data is just dumped and completely isolated. By contrast, a knowledge graph explicitly models real-world entities, like people, products, organizations, and the multidimensional relationships between them. It literally maps your unique business reality into a format that a machine can natively understand.
And it's this fundamental difference that's fueling the current retrieval wars: vector RAG versus GraphRAG. Now, retrieval augmented generation, or RAG, is used to ground AI responses with proprietary data. Standard vector RAG takes documents, arbitrarily chops them up into small chunks, and maps them mathematically. But doing that completely destroys the structural integrity and severs explicit relationships. GraphRAG, on the other hand, integrates structured knowledge graphs directly into the pipeline. It extracts entities and relationships, stores them as a graph, and utilizes explicit graph traversal during the actual query phase.
If you're wondering why this structural integrity actually matters, consider this wildly shocking metric. In rigorous industry benchmarks evaluating schema-bound queries, so things like key performance indicators and financial forecasts, standard vector RAG scored a catastrophic 0% accuracy rate. 0. It completely failed at multi-hop reasoning.
GraphRAG steps in and fixes this catastrophic failure by providing deterministic constraints. It essentially adds a robust computation layer right on top of semantic search. It navigates explicit edges to group, filter, and accurately count entities before it even passes context over to the LLM. Because of this, engineers can actually debug the logic. It's a total game changer because it allows organizations to build genuine institutional trust. Sanctioned systems can show exactly which governed data a model actually used.
Which brings us to Section 3, Real-World Transformations, AI Agents in Production.
When data infrastructure is actually clean, AI ceases to be just a cool novelty and becomes a massive business driver. Just look at the results across different sectors. In finance, the Totality Payoff Analysis agent acts as an autonomous assistant for mortgage lenders. It autonomously extracts financial data from messy, unstructured spreadsheets to compute exact payoff metrics. Over in healthcare, supported by knowledge graphs mapping complex medical ontologies, agents securely analyze real-time patient streams and safely cross-reference contraindications to suggest HIPAA-compliant dosage adjustments. And in telecom, companies like Qualio Technologies use knowledge graphs to model massive metadata sets. This allows AI agents to autonomously trace metadata lineage and verify compliance status using natural language, all without breaching security protocols.
The return on investment is crystal clear, and trust me, the market knows it. Global AI spending is projected by Gartner to hit $2.5 trillion by 2026. But the real story here is where all that money is actually going. Spending specifically on AI data foundations is exploding by nearly 277% year over year. Enterprises are frantically scrambling to build out these AI-ready architectures.
Okay, let's look at how to actually pull this off in Section 4. The Data Readiness Playbook, Executing the Transformation.
Before you even think about handing over the keys to an autonomous AI agent, you absolutely need a highly actionable playbook. It starts with inventory and visibility. This means creating an exhaustive catalog of all your enterprise data sources and defining really clear owners. From there, you've got to move to quality and cleansing. This is executing baseline standardization, like converting dates to a universal year-month-day format and handling missing fields programmatically. Next up is logic mapping. This is where you take your enterprise logic and terminology and translate it into the explicit ontological schema that governs your knowledge graph. And finally, traceability and lineage. You have to ensure meta tagging is a standard architectural practice so you can continuously verify the outputs.
And that leads us to our final imperative in Section 5, the Active Governance Imperative, Real-Time Controls.
Because autonomous agents execute actions and manipulate data at literal microsecond speeds, relying on manual human oversight for every transaction is simply no longer feasible. It's impossible. Governance must evolve into an active, centralized infrastructure layer that enforces dynamic policy at runtime. And with the emergence of strict regulations like the EU AI Act, AI compliance spending is soaring toward $1 billion by 2030. Automated policy enforcement and centralized evidentiary reporting aren't just nice-to-haves anymore, they are becoming totally mandatory for managing AI at an enterprise scale.
To make all of this actually work, leading organizations are aligning these new governance infrastructures with standardized frameworks. The NIST AI Risk Management Framework breaks this down into 4 core actionable pillars: govern, map, measure, and manage. By adopting this framework, regulated enterprises can blend NIST-style governance with incredibly strict security controls, ensuring that automation never outpaces safety.
I want to share a pretty stark warning directly from industry analysts. They state, without absolute trust in the underlying data, the outputs of the models, and the decision-making logic of the agents, an enterprise will derive zero sustainable value from artificial intelligence. This really hits the nail on the head and drives home the core takeaway of this entire explainer. Highly sophisticated AI engines are incredible tools, but they absolutely cannot manufacture facts out of data chaos.
Look, tackling your data debt and building out knowledge graphs isn't exactly the glamorous part of AI. But as we've seen today, it is the absolute fundamental prerequisite to unlocking the exponential productivity promised by the AI revolution. Which leaves us with one final, provocative question for your own enterprise AI roadmap. Are you building on a foundation of governed data or a foundation of hype? Think about it.